2025. Okay, so today we're skipping the usual, the press release hype cycle. Our mission is pretty surgical.
Yeah.
We are focused only on what actually shipped this week, what really scaled up, and where the operational edge of AI genuinely moved. We're really trying to look past the flashy announcements to the practical stuff. We're talking faster models, cheaper models, agents that are measurably sharper, and the infrastructure underneath it all, which, frankly, looks more like serious power engineering these days than simple web hosting.
Yeah, it's fascinating, isn't it? You can really see how the engineering necessities are basically dictating the roadmap now. The pattern is tight. It's all driven by efficiency and, well, the need for immediate measurable impact. To really get a handle on this, you almost need to think like a product owner, assessing the ROI. So we boiled everything down into 3 clear themes for you: the race for efficiency, AI's real-world wins, and the $3 trillion foundation that all this stuff is built on.
Okay, let's dive in. Segment 1, the race for efficiency and latency, the lean machine. Let's start right there. At the operational level, models getting faster, cheaper to run. Because, when you're serving billions of requests, even a tiny optimization, well, it adds up fast.
Absolutely. This whole first theme, it's really about optimizing what we call quality per token and just ruthlessly cutting latency. Google DeepMind's latest previews for Gemini 2.5 Flash and Flash-Lite show this perfectly. They are literally trimming output tokens, Flash-Lite by about half, the main Flash by roughly a quarter.
Okay, hold on. If they're cutting, say, a quarter of the output text, is that affecting the model's voice or its ability to handle complex stuff? Or is this just like surgical optimization?
It looks surgical, yeah. The sources suggest they're maintaining quality, maybe even improving it in some ways. Crucially, they actually got a 5-point jump on the SWE Bench Verified benchmark.
SWE Bench Verified, right. For you, the listener, who might not follow developer tools super closely, what does that mean?
It measures a model's ability to autonomously find software bugs, write the fixes, and actually apply them. So a 5-point jump. That means these leaner models got significantly better at self-correction. That's a key operational win. Huge.
Okay, interesting. Now, if we shift gears from text efficiency to real-time conversation, the demands just skyrocket. Right?
They really do. And that's where Alibaba's Qwen3-Omni is. Well, it stands out. This thing is an all-modal engine. It hears, it sees, it speaks, and it's achieving sub-second latency for the speech output.
Sub-second, wow.
Yeah, it pretty much eliminates that awkward pause you usually get with conversational AI.
Okay, sub-second latency for complex audio rendering. That sounds wild. How do they even do that? How do they get around waiting for the whole response to generate?
They've tackled it architecturally. They're using something called a thinker-talker split.
Thinker-talker.
Yeah, and also this multi-codebook design. You can kind of think of the multi-codebook part as breaking the sound down into multiple parallel streams. So the audio can be built up and rendered incrementally, piece by piece, instead of waiting for one big output block.
Ah, okay, so it starts talking sooner.
Exactly. And this is crucial because it gives developers, a single production-ready stack for these real-time assistants. It replaces those brittle, sort of stitched-together systems we used to have, the separate ASR, LLM, TTS components. Much cleaner.
Right. And this focus on speed, on being frugal, it's not just for these massive general models, is it?
Yeah.
We're seeing the same clever efficiency push in really specialized tools, too?
That's exactly right. Take forecasting, for example. It's often a real pain point because you need results before you have enough data, enough history to properly train a model. So enter TimesFM-ICF. This model tackles that data scarcity problem using something called in-context fine-tuning, or ICF.
ICF. Okay, can you break that down quickly? How is it different from the usual fine-tuning process?
Right. So traditional fine-tuning means costly retraining runs. ICF is different. It's specialization at inference time. You basically just feed the big pre-trained model a few related historical examples right there in the prompt, and bam, the model instantly specializes its forecast for that specific time series you care about. The source material noted it beat the base TimesFM model by almost 7% on unseen data just by feeding it those neighbor series examples.
Yeah.
It's kind of a quiet innovation, but it saves serious money. It lets one robust forecasting model specialize really fast without those expensive retraining cycles.
Okay, makes sense. So let's move on. Segment 2. AI's real-world wins, sharper agents and measurable outcomes. So we're moving from just raw speed and efficiency to specific measurable applications. This is where AI stops being, just a cool tech demo and starts becoming a tool that actually delivers provable results in learning health complex tasks.
Exactly. The key theme here, I think, is using AI to provide structure, agency, effectiveness. Not just novelty. Look at education, Google's Learn Your Way project. It reframes static textbook content into these personalized multimodal lessons. It can rewrite stuff to the right grade level, spin out mind maps, even add narrated slides.
That sounds really useful on paper, but does it actually work? Is there proof?
Well, the efficacy study they cited is pretty compelling. It showed an 11-point gain on retention compared to just using a standard digital reader.
11 points. That's huge in education research, isn't it?
It really is, and it's backed by their pedagogy-tuned LearnLM model. So, look, this isn't AI replacing teachers, right? It's AI enhancing how core material gets delivered, and the data seems to show it helps.
And we see a similar kind of structural approach over in Taiwan with that Telper AI tutor for fifth-grade math.
Yes. Tallerber specifically pairs Socratic questioning, asking guiding questions with Polia's classic problem-solving steps.
Oh.
And the sources highlighted something interesting. The biggest gains weren't with the top students. They were seen with the struggling learners. Yeah, they benefited most from that structured, guided prompting. It helps manage their cognitive load, basically.
That focus on structured dialogue. It seems to carry over into healthcare search, too.
Yeah.
The Wayfinding AI from Google sounds fascinating because it flips the usual script, right? Instead of just dumping results on you.
Totally. Instead of that massive wall of text you have to sift through, it actually engages in a dialogue. It actively asks you up to 3 targeted questions per turn to really refine the guidance it gives you. And the interface is clever, too. It uses a split view, so those clarifying questions and your answers stay visible.
Okay.
This apparently helps users provide context they didn't even realize was relevant. And in randomized studies, it improved helpfulness and efficiency.
And this idea of precision, we also see it guiding actual medical procedures.
Exactly. There was a crucial survey confirming the path to better prostate cancer diagnosis. It combines the best imaging, that's multiparametric MRI, with fusion guidance, and then AI that segments and explains any anomalies it finds. The goal here is twofold. Faster treatment, obviously, but also, critically, fewer unnecessary invasive procedures.
Okay, let's pivot slightly to the enterprise. For professional users, choice is becoming a feature. That feels like a big development. Microsoft 365 Copilot is adding Anthropic models.
This is genuinely monumental, yeah. Users can now actually choose models like Claude Sonnet 4 and Opus 4.1 right inside Copilot Studio and Researcher. That kind of model diversity, it's a potential game changer for businesses. They can now A/B test quality versus cost for different internal tasks.
But more choice often means more friction, doesn't it?
Yeah.
Where's the catch? Is there a compliance issue here?
Yes. There's the crucial caveat. The thing admins absolutely must look at is that the Anthropic models, in this specific integration, are hosted outside the standard Microsoft-managed environments.
Ooh.
So yeah, compliance teams, data residency policies, they need to catch up quickly to this new level of provider choice.
All right. And moving into the creative space, we see AI proving useful when it actually respects these highly specialized workflows. Marika's Rap-First AI got some recognition. Why?
Because it respects the producer's workflow, their need for control. It generates stylistically coherent beats, trap, drill, lo-fi, and it prioritizes texture and groove. But importantly, it intentionally leaves creative space open for the artist.
So it's an assistant, not a replacement.
Exactly. It's useful AI meeting people where they already work, augmenting their process instead of trying to dictate the final creative calls.
Okay, segment 3, the foundation and the friction, infrastructure, strategy, and risk. Let's shift focus now to the absolute bedrock of all this. None of these models, none of these applications work without the money, the power, the incredibly complex supply chain. It really all starts with the physical reality of the data center.
Yeah, if you connect the dots to the bigger picture, infrastructure is truly the frontier right now. The scale is just staggering. We're talking about the $3 trillion AI data center build-out that's currently underway. And these centers, they're incredibly dense. They need immense power, massive cooling, and the sources highlight this as becoming a real issue. Water use, for example, is turning into a local political flashpoint in some areas. It's driving operators to look for things like off-grid power solutions just because the energy demand is so unbelievably high.
And that intensity of demand, that need for scale, it leads directly to consolidation, doesn't it? Where compute meets product at the absolute highest level. We saw Nvidia making a huge strategic move.
A huge bet. Up
Right.
to $100 billion invested in OpenAI, specifically to supply chips for their next wave of training and serving these models. Now, this isn't just, a simple sales transaction. It anchors NVIDIA's demand for years to come. And it effectively means that model roadmaps and compute roadmaps are becoming, well, they're like joint ventures now. Supply security is the ultimate differentiator.
And we're seeing a similar push for that kind of full-stack control from competitors, too, like Alibaba.
Yep, with their EPSAR Moves initiative. They are clearly positioning themselves as a full-stack player. They've got their own Nvidia partnership. They're doing a global cloud build-out, expanding into places like Brazil, France, the Netherlands, and they just launched their trillion-parameter Qwen3-Max model. The underlying message seems to be, you can't fully trust the models unless you control the entire pipeline, basically from the silicon all the way up to serving the results.
But the choke point, the bottleneck,
Yeah.
it still remains supply, right?
Yeah.
Specifically memory, which sounds less glamorous than GPUs, but it's absolutely critical.
Oh, totally critical. Samsung is pushing hard, desperately trying to regain market share in AI memory that's high bandwidth memory, or HBM. They're shipping to AMD and Broadcom, and they're vying for leadership in the next generation, HBM4. And this matters deeply because HBM acts as a direct throttle on GPU performance. You can have the fastest GPU, but if the memory can't keep up.
So HBM is the new bottleneck then, if memory throttles performance. Is this HBM4 race really just about raw speed?
Yeah.
Or is it more about maximizing how much usable compute you can actually cram into these hyperdense data centers?
It's definitely the latter. It's all about utilization, memory execution speed, memory bandwidth. That's what decides the real leaderboard for who can actually scale these things reliably and cost-effectively.
And infrastructure stability is also paramount. We saw that proven painfully with the JLR cyber crisis back in late August.
Oh, yeah. That attack just froze their production across multiple countries. Why? Because the smart factory became a single point of failure. Apparently, segmentation, the ability to isolate different parts of the network, proved much harder than expected in practice.
Right.
So this raises a really important question, doesn't it? Resilience isn't optional anymore. It's table stakes. These smart factories, they need hard isolation plans built in, not just elegant interconnected designs. Because if you lose access to your design tools, your manufacturing systems, production across the entire ecosystem just grinds to a halt instantly.
Finally, we're seeing policy starting to respond to some of these real-world risks, particularly around human trust and dignity. Pope Leo XIV weighed in.
He did. He explicitly rejected the idea of an AI pope, which got headlines. But more importantly, he cited his own experience of being the subject of a convincing deepfake video. And that very practical personal experience really drove his message, which was a powerful call to defend truth, demand transparency from these generative systems, and always keep human dignity, human persons, at the center of the development effort. That framing, I think it's going to echo in policy debates globally. And then more locally, you see places like Northern Ireland with their Foresight Plan. It's quite pragmatic. A two-track approach, focusing on near-term gains from generative tools for small businesses, helping them adopt AI now, but also building longer-term pipelines for deep data and AI roles. Crucially, they're grounding their policy in measurable outcomes, like economic growth, GVA, and the number of AI-enabled firms.
Okay, so wrapping this all up, what does this mean for you, the learner? We've seen the stack tightening up, haven't we? Models are getting leaner, like Flash-Lite. Agents are getting smarter, measurably so, like Wayfinding AI. And the infrastructure underneath it all, well, it's become this massive, costly, highly strategic battleground where controlling the supply chain is basically everything.
Yeah, the practical takeaway here, I think, is that efficiency is really winning the day. While we talk a lot about trillion parameter models and these huge $100 billion investments, the quiet innovations, the ones really moving the needle operationally, are often about frugality. They're about clever architecture, not just brute force scale.
Yeah.
The game has definitely shifted from can we even do this to how cheaply, how reliably, and how efficiently can we do this at scale.
Yeah, think about some of the systems designed specifically to be lean. There's LCRNet, which is a crime pattern analysis AI. It uses something called simulated annealing sparsity.
Right, and just to quickly unpack that jargon, the sparsity basically means training the model to ignore unnecessary connections, making it lighter and faster to run.
Exactly. Or look at Apple's SimpleFold. It uses plain, standard transformers, nothing too bespoke to achieve competitive results in protein folding.
Yeah.
The frontier isn't just about sheer size anymore. It's also about simplicity, about clever architecture that lets these incredibly complex tools run fast, even on relatively modest hardware.
And this is really the nudge, isn't it? The thing that turns just listening to this into maybe taking some action. If you are building things in this space, ask yourself, where can you maybe swap out a big verbose model for a leaner, faster preview version? Or where can you add that crucial layer of explainability that helps users build the trust they need to actually integrate AI into critical workflows?
Keep exploring that essential balance between scale and simplicity. It seems to be where the real action is right now. And we want to hear from you. Tell us what you want covered next.